So light absorption, okay, we talk about chlorophyll in the plant, and in the eyes we have something called retinol. Retinol, well, this is another minor mistake in the slide. It should be called retinol. Should be called retinal. So it should be AL, not OL. So AL, retinal, it is one form of vitamin A that we find in eyes, in the retina, in the eyes, and it is something called chromophore. Chromophore. Something we call chromophore. Retinol, on the other hand, okay, retinol is basically vitamin A. As you know that, okay, vitamin A, we got it from, food, like carrot, or other vegetable. Retinol is basically, there's another name called vitamin A aldehyde. Vitamin A aldehyde. But this is A and then this is L. So AL, this is really bad handwriting. A L D L D H Y. So aldehyde, vitamin A aldehyde. So that's why we just shorted retinal. Okay. So theoretical retinol, we should call it retinal. It should be retinal in the eyes and chlorophyll in the plant. We absorb vitamin A from food, and then our body convert vitamin A retinol into retinal, so that we can use retinal in the eyes. Chromophore means that it is a molecule, light-sensitive molecule that that is a light-sensitive molecule. We call it chromophore. Okay, chlorophyll structure. So it's like a reveal. So we learn about photosynthesis. This is what a chlorophyll looks like. You see that it has a magnesium ion here. Magnesium ion in the center. And then these kind of like a double bond. Double bond, they are for light absorption. The double bond, they are for light absorption. That's how a chlorophyll can absorb sunlight. And then what about retinal? See, retinal is a retinal pigment. So retinol is vitamin A. Retinal is the retinaldehyde aldehyde. Retinaldehyde is basically vitamin A aldehyde or retinaldehyde, so that's why I call retinal, because it changes the OH group into C double bond O. This is an aldehyde group. And then you can further convert to retinoic acid or beta carotene. Okay. but you just need to know that, okay, vitamin A is retinol, right? The chromophore, the light sensitive molecule that is found in our eyes is called retinol. This is found in the eyes. This is vitamin A. So of course, our eyes is to capture the light energy. The light energy is transmitted in the forms of something called photon. When photon hit the retina, the light sensitive membrane in our eyes, then in our eyes we have something called photoreceptors. Photoreceptors, they are like chloroplast. Yeah, literally like chloroplast, and inside of a photoreceptor, we have lots of retinol. Retinal. Inside the photoreceptor, we have lots of retinal. We'll take a look at the details in the next few slides. This is the anatomy of the structure of the eyes. Okay. So light has to go through the cornea first. Light first will hit the cornea, and then you'll go through the anterior compartment. Anterior compartment contains something called aqueous humor. In this case, humor doesn't mean anything funny, or it doesn't mean a joke. Humor means a body fluid. So in general, all body fluid we call it humor. And then when light go through the so-called humor, then it will go through the pupil. Pupil is basically a circular empty space. The circular empty space is created by the muscle iris. And iris is the part of the eye that gives you the so-called eye color. So for many Caucasian, they have the eye color light blue. For Asian, our eyes is either brown or black or something like that. After the light goes through the pupil, the light will hit something called lens. Lens is a transparent tissue, and it is also elastic. And lens is we use lens to focus light onto the retina. So the eyeball has 3 layers. The so-called, on the surface, we have the retina. Retina is the one that has the light-sensitive chromophore, like retinal. Okay, this is the one that detects sunlight. Behind retina, we have something called choroid. Choroid, in human eyes, choroid is a dark black layer. It's a dark black layer. If you look at the old camera, those cameras that use film, you see that inside the camera is all black. Why? Because black environment minimize the reflection of the light. Similarly, when light hit the retina, and then when the light go through the retina and hit the choroid, which is mostly black, then it reduces reflection so that we don't see the glare or any kind of white spot or some kind of glare reflection from the light. Last but not least, the outermost part of the eye is called sclera. Sclera, they are thick white color tough tissue. So if you look into your own eyes in front of a mirror, you can see that, okay, the part of the eye that gives you eye color is the iris, and then surrounding iris, then you have something white stuff. Your eyes, some people say, well, your eyes is white, black or white, So the white area, the white tissue of your eye is called sclera. In other words, when you look at the eyes, your eyes in the mirror, you can only see what? You can only see cornea. Theoretically, cornea is the one that you put your contact lens on the surface, and then you can see the pupil, you can see the iris, you can see sclera. You cannot see choroid, okay? You cannot see retina. Well, you need special tools in order to see retina. Doctor has that tools to check your retinas. And then we call this a posterior compartment. Basically, anything behind the lens is the posterior compartment. It is filled with something called vitreous humor. Vitreous humor is a thick body fluid that maintain the pressure inside your eye. And then we have something called fovea centralis. Fovea centralis is ideally, it is where the image your lens focus at. So your lens focus an image at fovea centralis. Fovea centralis is the most sensitive part in the retina. It has the highest number of photoreceptors in the retina. And then the exit, remember the exit of retina. The exit of retina is the optic nerve. And the optic nerve, it also has the blood vessels to go in or out of to supply tissue, the eye tissue with oxygen and nutrient. So this is a schematic representation of the structure of our eyeball. You can see that the retina is the innermost layer, and then it is surrounded by choroid, and the outmost part is the sclera. Sclera is the white part that we can see from our eyes, and retina is the part that has the light-sensitive molecule retinol. So we already talked about this part, retina, choroid, and sclera. We also talked about the rest of it already, so I'll quickly move to the next slide. So what is the function of the lens? Okay, I already said that, okay, to focus light onto the retina. Specifically, it should focus on the fovea centralis. If you remember, I told you fovea centralis. This is a good point to mention in the slides. Image is inverted or upside down on the retina. Yes, it's like a pinhole camera. If you know anything about a camera or heard about pinhole camera, our eyes is actually a pinhole camera. So whatever image it is on the retina, it is inverted and upside down. And our brain get used to process this type of inverted upside down image. Basically, our brain automatically correct this correct the upside down image to become upside up image. Yes, if the eye was too long or too short, then we have to wear glasses. In my physiology class, I talk about this type of different correction, or you may call it different pathology of the eyeball, but we don't need to go into detail in here. So how do we see things? How do we see things that is close to our face, or see things that is farther away from us? Well, we adjust the thickness of the lens. In here we said that the lens will round up when we see things when we see close object. And it is by ciliary muscle. So what happens is that when we want to see object that is close to our face, then the ciliary muscle will contract. And ciliary muscle, contracting of ciliary muscle will relax something called sonnular fiber. This kind of sonnular fiber connects the ciliary muscle with the lens, meaning that the sonnular fiber is in between the ciliary muscle and the lens. So when ciliary muscle contract, it gets closer to the lens, and that relaxes the fiber. And then when the fiber relaxes, the lens can so-called bounce back to its original shape, which is more spherical, or you can call it round up. In this case, we can see closer object. On the other hand, if we want to see an object far away from us, what happens is that the ciliary muscle will relax. When the ciliary muscle relaxes, it will pull away from the lens. When it pulls away from the lens, it will also pull the sonnular fiber. When it pulls the sonnular fiber, then the fiber will in turn pull the lens. When the lens is pulled, then the lens will become flattened and thin. Then we can see object farther away from us. And the last point explains something. The elasticity of the lens may decrease with age, and because of that, it causes something called presbyopia. Presbyopia. Presby means elder. Okay, it's like Presbyterian church. Church is the kind of church that has elder. So presbyopia is the opia is the optic disease. You may call it optic disease. It's an optic disease in old people. It is because the elasticity of the lens decreased due to old age. Then the lens cannot round up, cannot bounce back to its original shape, so that old people can only see things far away, but they cannot see things close to them.